Stay up there.
All right, my apologies for the people at home.
Stay up there.
I am doing this in a different order. This says solve using substitution, but in the classroom we're starting with elimination. So we're starting with elimination problems. Okay? So what does the word eliminate mean in the real world? Okay, put your chair on the floor. Huh?
Exterminate.
Getting rid of something. Not necessarily permanently, but just getting rid of it. Okay? So we eliminate it. Alright, now. So what we're going to do is eliminate a variable. Yes, ma'am? You're going to do odd problems of all of the problems. You're just going to do 1 through, what, 12 or something?
So you want the odd ones on this?
Odd ones, yeah.
Okay.
Both sides. Odd ones, both sides. Alright, but we're starting at example 2A. We're starting at example 2A. Notice I skipped all these. Alright, we're doing example 2A. And I am eliminating a variable. To eliminate a variable, for example, I'm going to eliminate the variable x. What I'm going to do is I'm going to add the two equations, because 3x plus negative 3x goes to 0x, so I'm not even going to bother to write it. So I can do negative 5y minus 10y is negative 15y, and 28 plus 2 is 30. So the x is gone. So I don't bother to write the x. Because 3x plus negative 3x is 0x. I don't bother to write 0x. What part of that do you not understand?
Oh, it's going from up and down?
Yes, I'm adding it vertically. I'm adding the two equations together. You can't add 3x and 5y, because one has x and one has y. Continuing to solve it, I'm going to divide by negative 15. And I get y equals negative 2. I'm not finished. I need to solve for the intersection. I have the y so far. I need to get the x. So I'm going to take this number and substitute it into either equation. I prefer to plug it into the one with the least number of negative signs. So it's 3x minus 5. All right, so what have I done so far? I've copied the 3x from the first equation and then the minus 5, but I'm not going to write the letter y. I'm going to write in its place parentheses negative 2. So I didn't write the y, I wrote the negative 2 because that's what y is. I have replaced the variable y with negative 2. Now I'm going to work it out. So what is negative 5 times negative 2? Positive 10. So it's a plus 10. Okay, so all I've done is work out the negative 5 times negative 2. Now I'm going to subtract 10 from both sides. Divide by 3. And I get x equals 6. So my final answer is, remember it's an ordered pair. Which number goes first? The x value goes first. So it's 6, negative 2. That's my final answer. Are you alright?
So with all the examples, would you have to add these?
Huh?
So with all the examples,
No.
like that, would you have
There's
to
more. There's more. I always add. But I have to do something to add them. Like this one. Look at B.
And you subtract.
That's right. You could subtract them, but I always add. Because people mess it up when they subtract. So I'm going to change it so you can always add. Okay? It's been my experience that when people try to subtract, they just mess it up. So what I'm going to do is so that you always add. Because that's the way I'm going to teach it. If you can figure out how to do it by subtraction, great, do it. Just don't make any mistakes. Alright. Now, so look at this. If I add negative 2 and 4, do they cancel? No. If I add 9 and 9, do they cancel?
No.
See, you heard those people? 9 plus 9 is 0. Okay. All right, no. 9 plus 9 is not 0. 9 plus 9 is not 0. Okay. All right. So, but I know what the people were thinking. If you subtracted those two, they cancel, wouldn't it? But you can't. So what I'm going to do is change signs of one of the equations. I'm going to change signs of one of the equations. So I'm going to take the first one, and I'm going to change that negative 2x to a positive 2x. Change the 9 to a negative 9. change the negative 21 to a positive 21. When people do it this way, there's less mistakes. When people try to subtract, they forget how to subtract, or they forget to subtract some numbers. But if you remember to change all the signs of one equation, you'll be good. And most people are better at addition. I don't know why.
Wait, so we could have did that on the first one.
Huh?
We could have did that on the first one.
No. We didn't need to do that on the first
How
one.
do you know when?
Because it was already opposite signs. Okay, good question. He asked, why didn't I have to do it the first time when I have to do it this time? Well, on the first time, I had a positive 3 and a negative 3, and they cancel when you add them. Here, I didn't have anything cancel when I added them.
So you need something to cancel.
I need something to cancel, hence the name elimination.
Oh.
All right? So here, I have a negative 9 and a positive 9. Now they will cancel. Okay? So go ahead and add. So 2x plus 4x is 6x. The y's cancel, so I'm not going to bother to write that down. 21 plus 15 is 36. Yeah, that's right. Divide by 6, and I get x equals 6. That's 2 in a row. That's weird. All right. Okay. Now, am I done? No. What do I do?
On the Y.
Plug in
That's right. Pick one for me to plug it in. Which one to plug it in?
4.
No, for it.
Okay, the bottom one.
Yeah.
So I'm going to do 4 parentheses 6. And I always use parentheses when I substitute because if there's a negative sign, people screw it up when they don't use parentheses, okay? Alright, so it's 4 parentheses 6 plus 9y equals 15. Go ahead and work it out. 4 times 6 is 24. Subtract 24 from both sides. Divide by 9. So, final answer, 6 negative 1. You good? Alright, ready for example C? Example C. Okay, look at example C.
Nothing cancels.
Alright, nothing cancels. Even if you subtract them, nothing cancels. So we're going to just choose a variable to get rid of. Pick one for me, X or Y.
X.
Y.
Y.
Okay, here's what you do. You pick the one with a smaller number. X is a smaller number, so that means you're going to keep the number smaller when you have to multiply. Okay? So right now, I have nothing in front of X. What would be good to have in front of X so that it will cancel with negative 2X?
Negative.
A
Positive 2.
positive 2.
Positive.
Right? Because 2 and negative 2 will cancel. So you're going to take that first equation and multiply by 2. So that'll be 2x plus 2y equals 10. Right, dude?
Yes.
All right. Now we add the two equations. So negative 2x and positive 2x cancel each other. Negative 8y plus 2y is negative 6y. 20 plus 10 is 30.
Negative 5.
Divide by negative 6.
Or negative 5.
Why not? Y equals negative 5. Make sure you pay attention to the signs. Most common error on this chapter or this section is sign errors. So they'll get like y equals 5, and then for x they'll get like 6 million or something.
Huh?
Yeah, some ridiculous answer. Well, usually it's a weird fraction, like 17 over 15 or something. Actually, that's not too bad. All right. Okay, I'm going to stop rambling now and go on. So plug negative 5. I prefer to use the simplest one. I'm going to plug it into x plus y equals 5. So it'll be x plus negative 5 equals 5. Right? I replaced the y with negative 5. I guess I put in parentheses. All right, and then add 5 to get rid of that. So x equals 10. Final answer, 10 negative 5. Okay, I'm going to do 2 more examples.
So when it's like that, you always do the lowest number but opposite.
Yeah. If you have that option. Alright. Ready for D?
Yeah.
D. Okay. So this time, I don't have a variable that's by itself. Right? I have both variables are encumbered by another number. So you just pick a variable for me to give them.
Why?
Why?
I'll say X.
X?
X.
Alright, X.
I vote for X.
Okay. Why is X better? Because 2 is smaller than 6. That's the only thing. Okay? Alright, now this is going to get weird. So I want them to have the same number but opposite signs. I want them to have the same numbers. And I'm going to use multiplication to get them to have the same number but opposite signs. So remember how to do fractions? If I had a fraction like 1/2 and 1/5, what's the common denominator? 10. Do you remember how to do that? 10. If it's prime numbers, you can just multiply together. 2 times 5 is 10. Okay? So what I want is one of them to have a 10 and the other one to have a negative 10. Okay? I want one of them to have 10, the other one to have negative 10. So let's do the first one. So I'm going to multiply the first one by negative 5. Okay, I'm going to multiply by negative 5. And you're going to multiply the bottom one by 2. That's right. Okay? Because right now they have the same sign. I want them to have different signs. So I'll multiply by negative 5. I get negative 10x plus 30y equals negative 10. And the second equation, 10x minus 10y equals negative 10. Really? Did I make a mistake? Looks okay. Really? That's how my son says really. Really?
Does he live here or where does he live?
He's in China.
Huh?
Yeah.
So cool.
That's crazy.
That's crazy. That's crazy. There's 1 billion people in China. How's that crazy?
Where was he born?
China?
Oh my God. So you lived in China for?
Yeah?
I speak better English.
He just
than you.
like America.
为什么你不明白我? Why don't you understand me? All right. Okay, so when you add the 10x's, negative 10x plus positive 10x, they cancel. 30 plus negative 10 is 20, so it's 20y equals negative 20. Divide by 20, get y equals negative 1. Alright, I'm going to go ahead and plug this into the first equation. No particular reason. Alright, remember, make sure to plug it into the correct variable. Most common error on this section is plugging it into the wrong variable. So I have y equals negative 1. Some of you never write the variable, so you don't know which variable to plug it in. Make sure to follow through with your variables. So this becomes 2x plus 6 equals 2. Subtract 6. 2x equals negative 4. Divide by 2. X equals negative 2. Final answer is an ordered pair, negative 2, negative 1.
How did I write that without
Huh?
No, I was writing and not even looking at the paper.
Very good.
It turns out perfect.
That is okay. Alright, one more example. Why am I doing only one more example when there's
Because the other
two?
one's substitution.
Very good. The other one is substitution. So I'm doing example 3b. That's going to be the last one today. Example 3b. Ready? 3b. 3b. Okay.
I thought you were saying 3D. You saw me 3D.
All right. Pick a variable to get rid of.
I'm not even gonna speak because
X. What do I need to multiply one equation by to get rid of it? 2. We can multiply the first equation by 2, right? If I multiply by 2, I get a negative 4. Negative 4 and positive 4 cancel each other. So let's do that. Negative 4x minus 14y equals negative 36. What happens when you add the x's together? They cancel. What happens when you add the y's together?
They also can.
They also cancel. So the left side is 0. So you can't leave a side of an equation blank. You have to put something. When there's nothing left, you put the number 0. Okay, you can't leave it blank. And it's not 0y. It's just plain 0. What's 24 plus negative 36? Negative 12. Is 0 equal to negative 12?
No.
No, this is a
solution.
false statement. What?
Or no solution or false statement.
No, that's right. It's no solution. So false statement is not part of the answer, okay? This is just me emphasizing that this is false. So you don't need to write false statement on your paper. I'm just emphasizing that it's false. Because the answer is no solution. Okay, the answer is no solution. Now, what if you don't get a false statement? What if you get a true statement? Okay, so the true statement you're going to get is probably 0 equals 0, because that means everything canceled. Okay, so if it's 0 equals 0, then what's the answer?
All real numbers.
Okay, it's not all real numbers because it's not every number works. So when you give the answer all real numbers, that means it doesn't matter what you plug in, but it does matter what numbers you plug in. Okay, it's only numbers on the line. So you say infinitely many. Infinitely many solutions. So when you get 0 equals 0 or some other true statement, you put infinitely many solutions. And that's the end of the lesson.
couldn't you just put infinity equals infinity?
But that's another false statement. Because infinity is not equal to infinity.